All right, so this is a question that you guys asked for. So it's talking about one of those particle motion questions again. And it gives us a position function, which is right there, because keep in mind that I'm going to use yellow for position now. And then it asks us, when is the particle moving left or right? So moving means, I mean, if you think back, moving is this idea of how is position changing, right? Because that's what movement is. So how is position changing? That's what moving is. How's the position changing? So what we're really looking for is how is the position, when is the position moving left, or when is the position changing in the rightward direction? But again, moving is this, how is position changing? How is position changing? That's what movement is. So really, if I think about that, that's really just the derivative of position. So in this case, that would really be x prime of t. And in other words, this is really the velocity of t. Keep in mind, if a velocity is positive, I know it's moving, the particle is moving rightward. If velocity is negative, I know that the particle would be moving leftward. So I just really need to figure this out. So let's go ahead and get this velocity. I'm going to use blue for velocity at this point in time. So I need the derivative of position. How is position changing? So that's a derivative. So I'm going to go ahead and say, well, I know it's 3 multiplied by 1 over 2t minus 5, because, I'm going to use the chain rule here, and then multiplied by 2. Okay? So if we simplify this, we know that x prime of t is really 6 over 2t subtract 5. And this is our velocity function. Now, I really want to figure out when is the velocity, when is the derivative positive, when is x prime negative, which really means I'm wondering when could x prime change from positive to negative. So keep in mind that what we're really looking for then are our critical values, right? So I'm really looking for when is 0 equal to this thing, which using structure, I would realize that the numerator would have to be 0. So this is never 0. So never. Okay, or keep in mind we could actually have an undefined derivative, because we can change from positive to negative at undefined spots where critical values also are undefined. So what would cause that to happen? Well, if 2t minus 5 was equal to 0, which would lead us to t equals 5 halves. Okay, so really I have one critical value here. So that really kind of sets up my numbered line analysis, if you will. So I've got this time of 5 halves, but keep in mind that this time of 5 halves is the only time I'm really interested in anyway. Something's going on interesting on my iPad, but that's okay. So I'm wondering then, when is x prime of t positive or negative? So I'm going to go ahead and look after 5 halves. And if I plug in something after 5 halves, let's say, I don't know, we could plug in 10, right? If I plug that in up here, right, I would get x prime of 10 is 6 over, well, something positive. So that's really going to be positive there. So that x prime of t is positive on that interval. So, and it was actually undefined right there, not 0. Now, I could go ahead and look on the left, but that's not going to make any sense because natural log isn't defined there, and that's why I think they're giving me, this restriction. So ultimately, what I can see is that x prime of t is positive on the entire interval, which means, now I can go ahead and I can write my full statement here so we see what it looks like. The particle is moving right on, that specifies it's an interval, 5 halves to infinity, because x prime of t is greater than 0. And there is my full defense of what's happening with the particle. So that would be my solid answer. Now, so all of this is great, and I really just want to keep in mind what this, why this makes sense, So like Sam does for us, he constantly connects it back to algebra. So if I really think about what this function looks like, it's a natural log function. So it would look like this. But then I know that it, I can kind of figure out the rightward shift, and that I would realize that this function got shifted right by 5/2. And so it looks like this. And so that's actually our function here. And it's got vertically stretched too, but that doesn't matter. And if we look at this, we can see from that position function, so this is really x of t, we can see that our derivative, which is really just our, slope of a tangent line, those are always positive, and that's why x prime of t is always greater than 0 on that interval like we specified. So anyway, hope this helps.